So you may be wondering, what does balancing chemical reactions have to do with making burgers? Well, to make a burger you need a certain amount of ingredients. These ingredients can be seen as reactants and the burger as the product. So if we are planning to make one burger, we need a ratio of 1 to 1 to 1 to 2 of the ingredients. If we are making 3, we need a ratio of 3 to 3 to 3 to 6 of the ingredients. The amount I need on my product side is the amount I need to put in on my reactant side, and vice versa. For chemical reactions, it works the same. The elements on the left-hand side of the arrow must balance with the elements on the right-hand side of the arrow. Chemical reactions can be balanced in the following way. Write down the elements in the reaction on the left-hand side of the table. In this reaction, we have iron, oxygen, and carbon. Draw dotted lines vertically downwards where the plus signs are, and a solid line where the arrow is. Fill in the quantity of the elements already present in the reaction. Now balance row by row or element by element. In the first row, we have 2 ions on the left-hand side and 1 on the right-hand side. So we multiply the right-hand side with a 2. For the oxygen row, we have 3 on the left-hand side and 2 on the right. Here we then multiply with 2 on the left and with 3 on the right to get a total of 6 oxygens on both sides. Note that all elements in the same column must also be multiplied by the same number. We now move back to the first row and multiply the iron with a 4 to have 4 ions on both sides. In the last row, we multiply the left-hand carbon with a 3 to balance the chemical equation. Pause the video and first try to balance the reaction yourself. In this reaction, we have 2 nitrogens and 2 hydrogens on the left-hand side of the arrow, and 1 nitrogen and 3 hydrogens on the right. To balance this reaction, we multiply with 2 to balance the first row and with a 3 to balance the second row. Pause the video and first try to balance the reaction yourself. In the next reaction, we have nitrogen, hydrogen, sulfur, and oxygen. First, we fill in the quantity of each element in the table. To balance the first row, we can multiply with 2 in the first column. In the hydrogen row, we now have 6 plus 2 hydrogens on the left-hand side, which balances with the 8 hydrogens on the right-hand side. Please note that over a dotted line, we plus numbers. For the last 2 rows, we can see that the sulfur and oxygen are already balanced. Our balanced chemical reaction looks like this. Pause the video and first try to balance the reaction yourself. In this neutralization reaction, we have sulfuric acid that reacts with sodium hydroxide. We write down the elements as well as the quantity of each present in the table. For this reaction, we start with the unbalanced single element that occurs in only one of the 2 compounds before and after the arrow. We then multiply the left-hand sodium as well as the column which it is in with 2. If we multiply the water column with 2, our reaction is balanced. Pause the video and first try to balance the reaction yourself. For the last reaction, we look at a combustion reaction where butane is burned in oxygen to produce carbon dioxide and water. For a combustion reaction, we always balance it in the following order. First carbon, then hydrogen, then oxygen. To balance the carbons, we multiply with a 4 on the right. For the hydrogen, we multiply with a 5. For the oxygen row, we have 2 on the left-hand side and 8 plus 5, which gives us 13 on the right. When we end up with an odd number like this for oxygen in a combustion reaction, we write the odd number in front of the oxygen molecule and multiply the rest of the equation by 2 to balance the reaction. For more videos like this, please like this video and subscribe to my channel.